So let's start with the introduction to radio access network. So what is radio access network, no, or RAN? To set stage, so let's start this brief overview of what RAN is and its role in the telecommunications ecosystem. Okay, so radio access network, these are commonly known as cell sites. These are strategically placed to provide wireless coverage to users within a specific geographic area. And you can see it all around you. Okay, you can see it everywhere actually. And the placement of radio access network or RAN components, such as the cell site, is critical to ensure that users have reliable and consistent access to the network services they need. So when you're planning the deployment of radio access network, network operators consider various factors such as the population density, okay, topography, building density, and traffic patterns within the coverage area. So by analyzing these factors, network operators can determine the optimal location and configuration of RAN components to ensure maximum coverage and capacity. So like for example, in urban areas with high population density and building density, network operators may need to deploy more cell sites with lower output power to provide coverage to smaller areas. While in some rural areas with lower population density, network operators may need to deploy fewer sites with higher output power to provide coverage to larger areas. So the placement of radio access network also affects the overall network performance. As you can see, we need to put a lot of cell sites in different parts of the Philippines, like for example, just to provide seamless coverage and mobility. Okay, so we need to be strategic in placing this radio access network. Now let's see the mobile network coverage. Okay, network now. So we need to put a different radio access network in different places. Okay, because the output power of this radio access network or cell sites is just in a typical, like for example, from the radio, typical is 20 watts, 40 watts, or 80 watts in some extent. No, that's why the coverage is very limited compared to a broadcast station. Okay, and the tower height of this radio access network, probably the highest might be 50 meters or 60 meters in height. Very frequent, you can see 100 meters of a cell site. Unlike the broadcast stations, which you can see around 100 meters and then transmitting at a higher power rate. Okay, so you need to put a lot of cell sites in different parts of the country to create a seamless coverage. Okay, so thousands of radio access elements create seamless coverage and mobility. So whenever you want to go from one place, from Manila going to Pampanga, so you will have a seamless coverage. You will not make a drop call. Wireless telecommunication system components are composed of three main parts. We have the user terminals. So the user terminals, these are the user equipment for 3G, 4G, or 5G. And also a mobile station if you're using a 2G. Okay. So the examples of these are user terminals such as smartphones, tablets, laptops, and other mobile devices that are equipped with wireless connectivity features, such as the cellular from 2G to 5G. And then the user terminals are connected through the radio access network or RAN. So the RAN is responsible for providing the wireless connectivity required for mobile devices to connect to the core network and access the services. So the radio access network includes different parts of antenna system, radio, and the baseband unit. Okay, so these two are connected via air interface. So we are using a wireless connectivity. We are using a different frequency, set of frequencies. We call it the radio frequency. Okay, and the radio access network is also connected to the core network or the CN. So the core network is responsible for managing the overall operation of the network. So it includes routing traffics between different networks and providing advanced services such as voice calling, messaging, and data services. And there are different means to connect the core network and the radio access network. So these are connected via microwave wirelessly or physical cable or fiber optic. And if there's a challenge in terrain or large distances, and then you are limited by the curvature of the earth, you will use a satellite, okay, to interconnect these two. Okay, so this is the main components of a radio access network, of a wireless telecommunication system. You have the user terminals connected to the radio access network and core network. Now let's focus on the radio access network. So radio access network, this is the one, this is the part of a wireless telecommunication system that is nearest to the subscribers. Okay? You see it all around you. Kahit saan pwede mo makita to. You can see it in the malls, you can see it on mountains, rooftops, wall mounted on a building. Okay. And the location is widely distributed. So you can see it everywhere. And since it is transmitting not high power, thousands of RAN elements create seamless coverage and mobility. So RAN is all around you. Okay. Have you ever stopped to think about how your mobile device or cell phone is able to connect to the internet and make calls and text while you're on the go? It's all thanks to radio access network that's all around you. Okay, so next time you're out and about, take a look around you. So you'll likely see cell towers and antennas on top of a building, okay, or along the side of the road, or even in the mountain, or even inside the malls. So this type of antennas, okay, are inside the malls. So we call it the in-building solutions. Okay. So when you look at outside the malls, mamaya makita nyo, no? Meron tayong mga antennas like this. So some people, napagkakamalan nila yung Wi-Fi access points. Okay, but it's not a Wi-Fi access point, no? It's an omnidirectional antenna, or sometimes an active antenna that belongs to a radio access network. Okay, so if you take a look on the overall architecture of an IBS, the IBS is looks like this, no? So if you will have a building like this, you have a ground floor or second floor, the equipment are located most of the time either in the ground floor, basement, or on the rooftop or roof deck. So you have this battery unit, the cabinet, the transmission unit, and the remote radio unit. And what is unique in the indoor system, like what you are seeing inside the malls, these are using distributed antenna system, or DAS. When you say distributed antenna system, just imagine the electromagnetic energy is being distributed equally or almost equally in every parts of the building. It's just like a water sprinkler, right? So you have a source of water supply, and then you separate those water with different tubes and sprinklers. But this time, the water is now an electromagnetic energy which is invisible to our eyes. Okay, so this is what we call the distributed antenna system. Okay, so when you look at this, so there's an electromagnetic energy radiating in from these omnidirectional antennas, and also from these directional antennas. So this is how the typical in-building solution works. Okay, so this is not a Wi-Fi access point. So these are cellular network.